Hey guys, welcome back. My name is Vishwagatu and this is VG Studios. If you're new here, I make Python tutorials regularly with the aim to teach my viewers how to code Python and to inspire more people to start coding. If you've been following along, we have been learning about lists, and in my last video we learned about lists and list operations. Since this chapter is a bit long, we shall finish it in this video. So today we shall continue from where we left off in the last video. Today's topic is list algorithms and functions. Firstly, let's talk about list algorithms. In my previous video on algorithms, I explained that algorithms are a set of rules that need to be followed by the computer while carrying out operations. Hence, list algorithms are pretty much the same, but they're for lists. The most common list algorithms include filling, combining, separating, swapping lists, performing linear searches on lists, and so on. So let's start with a list algorithm to fill the list. Let's say we have a list A is equal to empty list. To fill it up with integers from 0 to n minus 1, we can say for I in range of n, A dot append of I. To combine all the elements of a list into an integer, we can say result is equal to 0 for I in A, result plus equals I. And if you want to change this to combine the elements to give you a string, we can simply change the result to. Next, if you want the elements of your list to be displayed well while printing them, such as separating them with commas or adding spaces between the elements, you can do this. Let's say my list is equal to 12, 43, 54, 24, and 78. Then we can simply say for I in range of len of my list, if I is greater than 0, separator is equal to separator plus comma. Separator is equal to separator plus my list of I. And finally, print separator. This shall print the values of the entire list separated by commas. But in case, let's say, you want to print the values with spaces in between as opposed to combining them in a list and separating them with commas, we can simply do this. For I in range, len of my list, if I is greater than 0, print line end is equal to print my list of I, comma, end is equal to. We can also use for loops to find the smallest and largest values in a list. Note that as we discussed the min and max functions in the previous chapter, which are much easier to use. However, these loops shall be helpful while practicing loop operations in lists. So this is how to get the smallest and largest values in a list. Smallest is equal to my list of 0. For I in range 1, len of my list, if my list of I is less than smallest, smallest is equal to my list of I. Next, largest is equal to my list of 0. For I in range 1, len of my list, if my list of I is greater than largest, largest is equal to my list of I. Next, if you want to perform a linear search operation on the list to find a specific element in it, let's say in this case 24, you can use a while loop like this to find the element. Element is equal to 24. Position is equal to 0. Found is equal to false. While position is less than len of mylist and found is equivalent to false if element is equivalent to mylist of position, print element found at position position found is equal to true. Else position plus equals 1. If you want to swap the positions of two elements in the list, you can simply do this. Let's say you want to swap the first and fourth elements in my list. You can first set a temporary variable to hold the first value like this. Temp is equal to mylist of 0. Then change the first value to the fourth like this. Mylist of 0 is equal to mylist of 3. And then assign the temporary value to the fourth element like this. Mylist of 3 is equal to temp. And you're done. Next, collecting and counting matching elements in a list can be done like this. To find and count all the elements above 50 in my list here, we can simply say limit is equal to 50. Result is equal to empty list. Counter is equal to 0. And for element in my list, if element is greater than limit result dot append of element, and finally counter is equal to counter plus 1. In fact, if you want to delete all these elements that satisfy the condition, you can simply say I is equal to 0. While I is less than len of my list, element is equal to my list of I. If element is greater than 50, my list dot pop of I. I plus is equal to 1. Else I plus is equal to 1. Next, we can use a list operation to take input from a user and add that to a list and stop when the user wants to stop. And that can be done like this. User list is equal to empty list. Print please enter values to add in the list or queue to exit. Choice is equal to input of quotations. While choice is not equal to queue, user list dot append of choice. And finally, choice is equal to input. Now let's talk about list functions. In Python, we can have functions that accept lists as arguments and carry out operations using them. If you want to define a function that takes a list as input and returns the sum of its elements, you can do this. Define sum of my list. Sum is equal to 0. For element in my list, sum is equal to sum plus element. Return sum. And if you want to define a function that multiplies all elements of a list by a specific number, you can say define multiply of mylist, comma, number. For I in range, len of mylist, mylist of I is equal to mylist of I times number. In Python, we can also return lists from functions. For example, if you want to return the list of all multiples of 5 from a list, we can say value is equal to 5. Define 5 multiples of mylist, comma, value. Values is equal to empty list. For I in range, len of mylist, if mylist of I percentage 5 is equivalent to 0, values dot append of mylist of I. Return values. This shall return the list values. Finally, today, as we have finished list algorithms and functions in Python, we shall have a bonus section, and in the next video we can continue with tuples, sets and dictionaries. Today's bonus section is tables. In Python, we can create two-dimensional lists to store values like a spreadsheet. These matrices are called tables in Python. Let's say you want to create a random table with 5 rows and 4 columns. That means that this table is basically a list of 5 elements which are actually lists of 4 elements themselves. In case you want to create an empty table first and add elements later, you can simply define a list like this. My table is equal to empty list, and elements later on like this. Rows is equal to 5, columns is equal to 10. For I in range of rows, row is equal to 0 times columns. My table dot append row. The elements in this table can now be accessed like this. If you want to access the first element of the fourth row, you can simply say my table of 4, 0. Just like in matrices, you can locate neighboring elements of a cell using its own row and column numbers. Here's a diagram to demonstrate this. In case you want to add more rows or columns, you can say for rows, total is equal to 0. For I in range of my table, total is equal to total plus counts I, j. For columns, you can say total is equal to 0. For j in range of my table, total is equal to total plus counts I, j. In case you want to calculate the sum of all elements of a table, you can say define sum of my table. Total is equal to 0. For I in range of length of my table, for j in range of len of my table, 0. Total is equal to total plus my table of I, j. Return total. With this, we're done with today's video and the chapter lists. So today we learned about list algorithms, loops in lists, list functions, and finally tables. Thank you for following along. If you liked my video, please don't forget to like, subscribe and comment on my video. And I hope you learned something new today. See you in the next one.